All right, these are the notes that we were working on. So it is a continuation of the 3-4 notes on linear programming. We had defined linear programming, constraints, feasible region. We had done 2 examples. So we set up our variables, our constraints, found x, y intercepts or points to use on our graph. We graphed them. And then the last part of it was to talk about the objective function, and we had it pretty organized on here where we had a place to list all of our vertices from the feasible region, plug into the objective function, and find a maximum for this problem profit. And then we made sure that we labeled it maximum profit with the $sign and specifically the ordered pair and what it meant. So now we're working on another problem. It's a little bit less led through. So let's go ahead and start this. We have a bookstore manager purchasing new books. They must have 320 feet of shelf space. So that is the total footage they need for the whole store. The first type of bookcase provides 32 feet of shelf and it costs $200. And the second type of bookcase, B, is 16 feet of shelf space and it costs $125. So with restrictions, so these are going to be part of our constraints, they have no room for more, or they have room for at most 8 bookcase A and at most 12 bookcase B. How many of each type of bookcase should the manager need or purchase to minimize the cost? Okay, so when we go to do this, it says how many of each type of bookcase. So how many of each bookcase? So this would be amount or number of bookcase A, and this would be number of or amount of bookcase B. Now, if we want to pull some of our information, bookcase A is 32 feet and it has a cost of $200. And bookcase B is 16 feet and it has a cost of $125. Now, 32 feet is double 16 and the price is a better deal than the 125. So most people would say get as many of these as you can. However, if you have part of a wall that won't fit a whole 32, maybe you can buy one of these. So we want to minimize cost. So my guess is we want as many of these as we can buy with minimal of these because this is not the better buy. So we're looking at this. They need 320 feet of shelf space. So that's going to go together here. So my constraint would be 32 feet times each bookcase A plus 16 feet times each bookcase B. So this would be all the footage from the first type and all the footage from the second, and he needs 320. So that means we can have that or more. So the feet go with the feet, total footage. All right, it's got to be greater than or equal to 320. All right, the next one, it said bookcase B has 16 feet of space. We've got that, the cost, and then it goes on, that has room for at most 8 of bookcase A. So bookcase A would be less than or equal to 8 and 12, at most 12. So bookcase B would be less than or equal to 12. Now, these are maximums, but we also need a minimum. So we cannot have negative, so x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Can't have negative bookcases. It didn't say they had to have at least 2 of these, so that we need to put the zeros in. Now, our objective was to minimize the cost. So the money goes to my objective function. So the total cost, we have P here, but it can be anything. It could be C for cost. And it would be here we have P equals, and it would be $200 for every bookcase A plus 125 for every bookcase B. So you have the cost times the quantity. That's all the money on bookcase A, and cost times quantity, all the money on bookcase B. So we're going to come back to this once we get the vertices. Now, in order to graph, again, I need to solve and find my x and y intercepts. So for this one, I will go ahead and do this in pink here. When I go to find my x-intercept, we would look at this and put the 0 in here. So it would be 32x is greater than or equal to 320. So divide by 32, we would get x is greater than or equal to 10. So 10, 0. And for the y-intercept, we would put the 0 in, and that would wipe that out, and I would have 16y is greater than or equal to 320. divide both sides by 16, y is greater than or equal to 20. Okay, so the highest y value I need is 20, the highest x value I need is 10. So I'm pretty set there. The x's are my vertical lines, cuts through the x-axis at 8, the y are my horizontal lines. So your objective function is not going to be graphed. We're going to come back to that once we find the vertices of the feasible region. Now, when you go ahead and set up your graph, I went ahead on mine and I counted by ones. Now, that did put me off a little bit. I just extended my graph, but I counted both by ones and I labeled my x and y axes. Go ahead and pause this, take a minute, and you can get your graph set up. And then let's check and see if we agree on the graphs we make. All right, so I'm going to do the first one. We got the x and y intercepts in. I'm going to do that in pink. So I'm going to go 10, 0, and 0, 20. So here I am at 10, 0. And off the graph here is 0, 20. And you can see I'd want to come down one and, well, it's not down one, over one. Up here, I just want to make sure that I hit these together. That is not, it would be down 2 and over 1. That would be my slope. So you can use a slope since we counted by ones on both, but I'm going to go ahead and just go intercept to intercept there. Okay, now that I've done that, I'm going to go ahead and put in my vertical line. So I have one vertical line. I'm going to put a little purple dot beside that at 8. Slope is undefined. So go ahead and push that through. And this one, x is shading less than, so we're bringing it and cutting off all of this graph. I should go back to my pink one. Both the x and the y were greater, so x was greater than 20, or y was greater than 20, and x was. So we're shading right now this triangular space up here, okay? Because we're shading this direction on the pink. Now, I have one more vertical line, and that's at 0, which actually gets thrown out. It's not part of the equation because we're cut off somewhere else. So we really need to graph that, and we're shading greater, but we're staying in this region. It would cut off this top part. And then we have our horizontal lines at 12 and at 0. So these have a slope of 0, and they are horizontal lines cut through the y-axis at 12. So here I go. That is going to shade less than this. So we would be shading coming down, so it's cut off the top. And then again, my y is greater than or equal to 0 is down here. And that has already been cut off by this point here. So our final shaded region is in this triangular section. So go ahead and shade that in. Maybe you're doing better than me. Okay. So from that shaded region that follows our vertices, or follows our constraints, we want to pull the 3 vertices. Since it's a triangular region, even though there's 5 constraints, only these 3 play a role in it. So down here, I'm going to bring down my objective function. We had it as P for the cost. It's 200x plus 125y. And the vertices that we have are down here at 8, 4. We have another vertice at 8, 12. And one more at 4, 12. Okay, so we need to take a minute and we need to plug everything in to find the values of P. So 200 times 8 plus 125 times 4. I'm going to run out of room here. P equals 200 times 8 plus 125 times 12. And for this top one, P equals 200, and this should not be there, times 4 plus 125 times 12. Okay, so not the best organization. I probably should have listed my vertices vertically so I could do this. And you need to go ahead and take a minute, plug these into your calculator to find the values of P for each vertex. Okay, so now that we've got our values, 8,4 gave me the value of 2,100, 8,12 gave me the value of 3,100, and 4,12 gave me the value of 2,300. So we want to minimize our cost. Now I have a star here because this one's down lower. This would be the highest cost, which makes sense because we talked about bookcase A being a better price for how many feet you get. So having more bookcase B would be a higher price. So our minimum would be right here. So I'm going to rewrite that. So the minimum cost is $2,100, and that minimum cost came from 8 bookcase A's. Those were the 32-foot ones, and 4 bookcase B's. So make sure if you're going to do all of this work and spend all of this time that you take the time to give your final answer as you would a report here, okay? It's the minimum or the maximum, what it is, $2,100, and what did it come from. Give more than just the ordered pair, give the ordered pair with the values. All right, there you go.